So till now what we have seen that, it is possible to get the hotspots, subsurface fire, with the satellite images that have a very coarse resolution of 1 square kilometer, means 1 pixel size is 1 by 1 kilometer. And the general practice is that to solve with some thresholding, either the classical threshold method or the contextual threshold method. And we have seen that there are a lot of problems while going through the contextual thresholding or the fixed thresholding method, so we have developed some algorithms. But still in that contextual algorithm which we have developed also, that have some problem is giving the more false alarm. What we are trying to achieve, the more adaptive method by which only with the image statistics or only with the image information we can able to detect the required target information. So for refinement, we have done some work, the machine intelligent approach for optimization and refinement of the hotspot detection model. So, but because till now it is only dependent on the image statistics. So if we want, so how we can train the data, because I don't know whether you have used some optimization technique or not. In a lot of optimization technique, what the people are doing, they are developing or some model, or they are trying to take one test site, and with that test site they are trying to train the data and applying on the whole data. So once your training will be wrong, so your whole result will be wrong. So you must have to take very care while once you are training the data for or developing the algorithm for optimization. So what we have explored, either some machine learning techniques will be helpful to refine the results which we are getting by our proposed contextual algorithm. So for this purpose, I am not going to give you details on the support vector classification or rough set classification. There are more than 10 types of most commonly used optimization techniques, but we have used here two: support vector classification, SVM, which is known as, and second one is the rough set classification. So again, the processing, we have processed the AVHRR, statistical analysis we have done, as I have already mentioned. Decision on pixel by conducting 5 tests, what we have done earlier, to know that either it is going through the hotspot or not hotspot. Then, but as I have mentioned, if I applying the optimization technique, it is very much required how you are training the data or how you are making the fitness function, etc. So if there is any error in that training the data set or fitness function, then your final result will be in a very different way. So we have applied the first approach in the support vector classification. So why this is the support vector? That is if you heard the name ANN, it is start neural network, then ANN. So anybody has read something about the artificial neural network or network? But if you will see the paper, after 2006, there is a very few papers by the ANN techniques. So, but why I am saying that every technique has their own limitations. So once it is coming in the picture, a lot of people are trying to use, okay, ANN we can use here, ANN we can use there. And but after using 4 or 5 years or 6 years, what people saw that there are a lot of limitations, because making the network, there are non-linear network, and for training the data set there is a lot of problems. So what we have, that analysis I am not showing here, but the support vector machine, this SVM technique of the classification or optimization has come in 1995. So as I have mentioned, once any time if you are trying to do the optimization technique, so you must be very careful while the training data and all the fitness function or the function by which you are going to optimize your any classification or any formulation. So minimize the, so it has some advantage. Minimize the error on the training data, has better ability to generalize. Based on the idea of structural risk minimization, which bounds generalization error to the sum of training set error. So main advantage of the SVM over ALN or any other technique is that it is minimizing the error on the training data. So we have done the classification. Training data means the data set for 25 to 2000 which we have used for the development of the algorithm. Then model generation, SVM model, predicted output. Then we have assessed the accuracy. Here we have put for SVM model, that is the training data, and for any optimization we have two things, test data and the training data, and we have gone through this process. So SVM, as I have mentioned, SVM has a upper hand on other like a neural network or genetic algorithm, that it is minimizing the error for the training data. So this is the some model. Now I think that there are open source code is also available. That is the live SVM, LIV SVM, the library SVM available. And this is based on the scaling. First you have to do the scaling, kernel function selection. There are 4 or 5 types of kernel function in which you have to select the function according to your requirement. Divided training data into a train data and test data set. Then train the SVM model, test accuracy. If the accuracy is acceptable, if accuracy is not acceptable, then again you can go through the same process. And then if accuracy is acceptable, then accepted the classification model. So the output what we have done, the output of the contextual model serves as the training data what we have developed for the contextual algorithm. Next one. Okay. So this the flow chart of this SVM, advantage of this SVM detail, if you want you can read by any literature or in the web, but I have got the advantage which I have already mentioned, that why I have chosen, why we are choosing the support vector classification. And here why I am discussing this, nowadays a lot of new optimization technique is there. Once you have to compare, and according to your requirement you can use any machine intelligence or soft computing techniques. Next. So what we have seen that, again, we have applied and we have seen that we can get, this is the raw image, and then once we are applying in the SVM, then we are getting the more refined result. This here, with the bright spots, it is very impossible to say that the more refined or not, but once we are doing the sub-pixel analysis, so we will able to say that either this result are more refined or not. Next one. So you can see that the three methods we have applied, FF fast forward, neural network, KNN, and SVM. And with the SVM, we are getting the classification accuracy better than the both two methods. Because once you are applying any method, so you must have to say that why you are applying this method and what is the accuracy with the other methods which you are getting. So next one. So again, this is the misclassification error or the false alarm. So what we are saying that once we are saying that in any image detection accuracy means we must have to avoid the false alarm or false misclassification accuracy. So what we are saying in the SVM, we are getting the better accuracy, and in the other hand, in the same way we are getting the less misclassification accuracy by the other two known methods, that is FNN. And one of the basic reasons behind that, they are taking a lot of error during the training set. So therefore, if you see the literature, latest literature after 2006, a very few papers you will be getting with the neural network, etc. And now with the genetic algorithm also, we are facing the same problem. Next one. So again, we have compared with our with the SVM, with the statistical analysis, with the data by the algorithm which we have proposed, and what we are getting a very good results. So performance, RPS, and contextual measure in terms of hotspot detection accuracy and the false alarm. So second method which we have applied, that is the rough set classification on no AVHRR images. This is again the decision of pixel of conducting 5 tests, then rough set classification. So again, there is a very good advantage of the rough set. It is introduced in 1980 and emerging mathematical tool to deal with uncertainty. Because once we are saying that it is a detection accuracy and all, so we are saying much more about we are talking much more about the uncertainty. So rough set is a tool by which we can know the uncertainty in the mathematical or in any detection accuracy. And another additional information is that it doesn't need any preliminary or additional information about the data, such as grade of membership of the value of mass bill in any fuzzy set or etc. And another important for this, rules which satisfy user specified minimum support requirement take part in the classification accuracy. So there are some possibility or there are some advantages by which we can apply the rough set method for knowing the uncertainty and we can classify our value. So just next. So we have done, this is the rough set classification process, decision system, risk standardization, redux, rule generation and the classification. Next. So this is the again how we are applying the rough set classification method. So first train the decision table. Again, this is optimization method. So we have to train and this is the training what we are trying to train to know the uncertainty in our results. Then discretization, discretization, and this is the unseen no AVHRR data. This is the potential hotspot picture information, and by using the both, we have done the classification. So finally, we got the another results.
Here even the classification depends on your role.
Yes.
If you are committing a mistake in that role, this is
Yeah. So why I am saying that? This why we have done, we have compared either the result which we are getting, the rules or with the training which our developed, either it is going to refinement, doing some refinement or not. Because if once we are going with the sub-pixel analysis, so for example, if we are getting in the same place 1 pixel or 2 pixel, so 2 pixel means 2 square kilometer. So that for that refinement we are just trying to do that either this is okay or not. Because again, why we are saying SVM has a less training effective. So it means what the model we have developed, if it is a less training effective, we are optimized, so possibility of error is less. Although I am not claiming that nobody can claim that it is a 100% error free, but some errors is there. And the same thing, once we are saying that it is uncertainty, because in the image it is a raw image, it is just a black box. So it is very difficult to say that the uncertainty doesn't exist. So there is uncertainty. So we have applied the two methods. We have applied more than 10 methods. And in all the 10, we have applied KNN, ANN, GN, all type of things. These two things we find that it is okay. This can be work for our refinement. Next one. So again, we have tested the sensitivity, specificity, and AUC. Just for a statistical test, to compare the things, either what the results we are getting, either it is in the right direction or in the wrong direction. Just why I am saying that these things you must have to remember or write down once you are trying to develop some algorithm or you are trying to do some research work. Next one. So this is again performance of the proposed hotspot detection algorithm. Region for the period of 1995 to 2005. Total number of existing hotspots are, we have detected 25 out of 70 very accurately. So total number of hotspots 25. In Dharia region, in Harmonic region there are 70 hotspots, major hotspots. But the image which we have required, that were only I think 30 or 35. But in that 25 hotspots we have very accurate. Next one. So we have again calculated all the SVM, statistical analysis, concept classification for the different tier NOAA, and you will be seeing that the graph is very random because all these things are based on the image statistics. So the quality of image also very much dependent to produce the accuracy. How much? Because for example, first image is 95, second image is 96. So in 1 year maybe atmospheric condition is changed or something is changed, so quality is changed. But we are getting, if you will see that with the statistical analysis, once we are trying to refinement, SVM classification or offset classification, actually with contextual algorithm what we are getting, this is the green one, the statistical analysis, that is the contextual one. But with the rough set or SBM, once we are applying the new machine intelligence approach, so our refinement means our accuracy gets increasing. So this is the purpose to show that once you have applied some threshold algorithm or you are developing some contextual algorithm for the segmentation of the image or for the enhancement of the image, you can try some machine intelligence methods also to refinement your result. So we have also applied some soft computing techniques, the same process to check either it is giving some better. And another very important thing why we are trying to do all these things, to minimize the to define the result in one hand and another hand to minimize the complexity. So what we have seen that, in last slide what we have seen that, what the contextual algorithm we are proposing, that is giving, once we are applying the SVM or rough set, it is giving, increasing the accuracy more than 10%. It means if we are applying the rough set or SVM, so it is useful while you are getting the more than 10% accuracy. Next one, soft computing techniques we have applied. Explore the applicability of the various soft computing tools and develop novel algorithms for hotspot detection, multi-channel information fusion techniques. So this was the main idea behind that for the application of the soft computing tools. Next one. So what is the difference between the machine intelligence and these words, machine intelligence techniques? I am talking in terms of machine intelligence because it is very much dependent upon the machine intelligence. So machine intelligence techniques need very complex mathematical models to develop solutions, and thus are very difficult to understand for the end user. Whereas soft computing techniques are less complex, do not require any mathematical model, and therefore very easy to implement. Because in first or second slide, I have mentioned that the aim of to diffuse or to disseminate the information to the end user with less complexity and with the most cost effectiveness. So therefore, we have seen that what is the effect of both. Next slide. So here we have applied the fuzzy logic approach and the principal component analysis. And these two approaches, what we have found that these two approaches are very suitable for this kind of target detection. If it is a very coarse resolution, if we want a very high refined type of target detection like a subsurface, so fuzzy logic approach. So this is a fuzzy classification. Satellite imagery has been used for a decade, and recently with AVHRR imagery, it is flexible, tolerant, because once you are using any method, any specified method, you must have to know that why you are using that. Flexible, tolerant, and imprecise data, and is based on the natural language. The system learns from example and experts. This is a very interesting thing for the fuzzy. It learns from its own, because in earlier slide I have already mentioned that what is the difference between the machine intelligence and the soft computing. For the machine intelligence, we have to train, there is a more complexity, whereas in the soft computing, it is less complex. And why it is less complex? Because it is taking from its own examples, experts' rules, and can adopt changes by mapping when new examples and experts' rules are available. No mathematical model is required for the problem. So this is the most important thing for the fuzzy classification. Next one. So again, we have used the pre-processing, multi-channel information fusion. So multi-channel information fusion, why I am saying that we have 5 band images, and all band we are using, and in that we have included 2 indexes, NDVI, that is the normalized difference of vegetation index, and MSAVI, because our aim, that is the modified soil adjusted vegetation index, because our aim is to get the information of the surface. So surface can be, we are thinking that surface information can be given by this MSAVI, and NDVI will give the information about the vegetation. So, and these are some relation. Next one. So then we have applied the fuzzy logic. So we have done the fuzzy inputs of the NDVI, MSAVI, band 1, band 2, band 4, band 5. We have put the values of lower, low 2, T4, T5, NDVI. Next one. So these are some methods. So we have seen that how the fuzzy inference system, because as I have mentioned that fuzzy is learning by this own example. So this is the fuzzy inference system, and this line represents the that I have already mentioned in the first flow chart, is the detectized the value. So how we are digitizing or how we are detecting the values of the different data sets. Next one. So basic structure of fuzzy system: input 1, input 2, input 6. There are 6 inputs. Then we have applied rule 1, rule 2, and then summation, and then we are getting the hotspots. Next one. Back. So finally, we got the again for the year 96, 98, 2003, 2004. But we have seen that in this fuzzy classification is also with the less complex method. It is also possible to get the classification of in the hotspot and non-hotspot pixels. Next one. So the degrees of membership for hotspots, what we have seen are the fuzzy number of pixels in the form of output response for fuzzy interference system. So what we are getting for the and degree of membership, once you are applying the fuzzy, so you must be with the level of confidence or degree of membership in more than 0.95 or more than 0.97. Next one. So comparison of existing technique, that is a simple multi-thresholding approach, entropy-based thresholding. Next one. So this is the fuzzy classification results what we are getting. So what we are getting, we have compared with the all. So this is the with the proposed method. This is a simple threshold, Iglo, Presso, entropy. Next one. So this results we got in the next one, principal component analysis. So this is the things which we are doing. Again, principal component analysis why we are using. I don't know whether you have read our principal. Principal component has a main advantage because it is reducing the dimension. Reducing the dimension means for fusion information we are using the PCA. For example, we have 6 input, band 1, band 2, band 3, band 4, band 5 and NDVI. So how the maximum information from one set of the data can be inferred in one component and given by the principal components. And this principal component output is given by the eigen numbers. So best eigen number which we are selecting, that is comparable or that is feasible for the classification accuracy. So these are some advantages for the principal component analysis. So express the input digital numbers in the original bands in terms of the new principal component axis. So that is the main advantage for that. Next one. So why I am showing these methods we can apply. Novelty of the proposed algorithm lies in the fact that hotspots are detected by applying PCA to low resolution satellite images. So next one. So again, as I have mentioned, this we have masked the image, masking the cloud, water and noise pixel, masking the then applying the principal component analysis. In principal component, we are getting first two. If it is a 6 input data, so we will be getting 6 principal components. So based on the 6, first the 3, on the basis of the eigen value, we have to select the best 1 or best 2 or best 3 principal component analysis. So on the basis of the eigen, because again it is giving some quantitative information. You have the things to select, because once you are going for the 6 principal component analysis, maybe you are losing adding a lot of noise. So by this, I am not showing all the details of this. Once we are applying how much results we are getting for 1, 2, 3, 4, 5, 6. So selection of first, selection of first 2 principal component analysis. We have select. So eigenvalues correspond. So these eigenvalues we have selected. First 2 principal component analysis we have selected for the year. But we are seeing that this is the eigenvalues and first 2 has giving the maximum values and less 3, 4, 5, 6 are the very less values. So we have selected first 2 eigenvalues for the classification of hotspot and non-hotspot values. Yeah. So information fusion. Yes. So here you are not seeing any. So we have used the information A, B, C, D and E. This is the immediate image C2E obtained as a result of applying image processing technique for the first two principal components. So this is the A, B, C, and we are getting here, I don't know, either you are able to see that these are the some red spots. So these are the some red spots here, these are some red spots here. These we are getting for principal component 1 and principal component 2. Next one, right? Iron hotspot here. So finally, we got some iron hotspots in large. So why I am interested to say that while we are using the information from the different channels, it is possible to, without having any mathematical formulation, you are able to get the hotspot detection. These points which we are allocated, you know that first, in the very beginning, I have mentioned that we are very much interested to know the latitude of longitude of the hotspot. In the image, we are seeing that, but you can see that this is the real Bokaro coalfield, this is the Jharia coalfield area, this is the Ragarajan, and we have compared our result by one mapping with the latitude and longitude, and we are getting very good results. So by this way, next one. So this area is the Bokaro steel plant. This is the Chandpura. This is the Bhayardri. This is the Katra. This is the Kirkera. This is the Jharia. This is the Patan. So these are the some hotspots, the known hotspots which we have detected without applying any mathematical formulation or something like that. So we have already been a detected hotspot, and we have compared the results with the other methods what we have applied for all 5 or 6 methods. So principal component analysis results, you are seeing that result is the classification HDA, the detection accuracy is varying from 75 to the 95%. Here one thing I would like to mention that here we have we want to put a measure for the image. Till now we have not put any measure for the image. What should be the image quality? So once we are putting a measure, if this image quality is good or not good or something like that. So either therefore we are getting, because these are the data for the approximately 15 years, 95, 96, 97, 98, 99. So every year the atmospheric conditions are changing, and these satellite images and visible region are very much weather dependent. So we are getting, sometimes we are getting the less change or high change, but what we are seeing that average accuracy is more than the 80%. Next one. So we have, what we have seen that with the fuzzy logic and PCA, with the same type of image, we are getting the PCA has some upper hand with these two type of image. So now what we are analyzing, why with the fuzzy logic, if we will see from 0 to 12 number of the 10th number of the image, means for the 10-year image, this is the image for every year for February only. So what you will be seeing that approximately we are getting the same, average is same, but here for these 4 or 5 images, these are a very different value we are getting with the PCA. So what we are trying to put some marker for the image, type of image or the quality of the image. And for that purpose we are working. So we are trying to process the image first for the quality of image, what kind of image is there, what quality of the image is there. So then we will be able to more accurately compare the results. Next one. So again, this is the most interesting part of the presentation. Till now, what we have done, we have applied, we have started with a very blank image where we are not able to see anything. Then what we have seen with the some known algorithm, with the some known playing methods, we have applied, we are seeing that, okay, it is possible to get the hotspot, but in another hand, a lot of false alarm are there. So, and false alarm are there in one hand, and another hand, it is very much dependent on your user's input. So what we are trying to do, how we can avoid the user's input. So only image can tell. You just put the image will tell, okay, either. So we have applied contextual. Then for refinement, we have tried for the machine intelligence and the soft computing both. Because ultimately, aim is the end user can get benefited with the less complex method or with the less complexity. So once we have trying to detect the hotspot, and it is with the satellite of a coarse resolution of 1 square kilometer. The second aim is that how you can estimate the area. But area is not 1 square kilometer large. It may be 500 square meter, it may be 200 square meter. So it is very difficult because pixel size in 1 square kilometer means you are just getting one reflectance from that pixel, either it pixel content, the water, building, urban, or etc. So we have done some hotspot harmonic analysis and the hotspot area estimation. Next one. So develop some innovative technique for monitoring. Monitoring means either the area is increasing or decreasing, or what is the nature of that, and then the estimation of the hotspot area using the subpixel technique. Next one. So harmonic analysis, I think that every computer science student, they have listened the word the Fourier transformation. So we have applied. What do you mean by harmonic analysis? Decompose a time-dependent periodic phenomena. Because we are trying to monitor the hotspot. In 10 years, what we have seen, either the hotspot is going to increase in 2 ways. Area is increasing and temperature is increasing. So how we can estimate, how we can monitor the thing? So proposed method takes into account temporal change in NVI. So we have done for this 95 to 2011. Next one. So we have applied raw data, any raw AVHRR, time series data we have applied for 10 years. Georeferencing, removal, harmonic analysis we have done. So for harmonic analysis, we have applied the decomposed sine and cosine functions like this, like the Fourier transformation, and because in Fourier transformation we are getting the amplitude as well as the phase information. So this A0 is the mean value of fx in a given interval, mean value of the fx. I think that everybody is knowing that. So we will be getting, ultimately what we are getting the amplitude of the nth harmonic, phase angle of the nth harmonic. These two information is very important to say that what would be the criteria, what is the either the hotspot is increasing or decreasing or something like that. Right? So we have land feature classification. We have applied all the first we have cloud and water, medium forest land, and then detected hotspots, segmented amplitude image. As I have mentioned, after the Fourier transformation, what we are getting the amplitude information, and then we have collected the information from the mean and pixel. Next one. And this is the fundamental amplitude image. It will this is a more gray and less gray image. Band 1 and band 2 and NDVI. This is the band 1, band 2. This is the amplitude image. Next one. I will show you some. So this is the forest land, this is the water body, this is the hotspot. So you can see that classified AVHRR image we are getting in this. Again, first we have applied for the classification. Next one. So again, the error matrix generated for the classes. This is again for the testing, how much classification accuracy we are getting. Next one. Next, again, this is the same type of analysis. Okay. One, I think that one slide is missing where we have plotted the intensity of the intensity of the hotspots, and we have shown that either this hotspot temperature is increasing or decreasing. Maybe I think that is in the last I don't remember. So again, so by harmonic analysis, what we have concluded that by the harmonic analysis we are able to detect the hotspot with that intensity variation. Amplitude variation means intensity variation, how the intensity is compared to 1 year to another year. And then for the subpixel analysis, for the area estimation, we have done the subpixel analysis. And for doing the subpixel analysis, there are two very common methods, that is the linear and non-linear methods. And because subpixel means your one image is 1 square kilometer, in that you have a lot of variety of land cover. Land cover is water, urban, etc. etc. How you can do things with the subpixel analysis, and for doing the subpixel analysis, you must need a very high resolution data. So fuse the information of the high resolution data on the low resolution data, then you will be getting the information of the subpixel. For example, if you have a 1 square kilometer pixel is area of one data, and another data you have a 12.5 meter square. So 12.5 meter pixel is the very high resolution pixel, whereas 1 square kilometer is the very coarse resolution pixel. So what we are doing, we are trying to fuse information of the 12.5 meter square in the 1 square kilometer. But in another hand, you must be very careful while using the things. The reflectance value means the bands approximately should be the same. For example, you cannot fuse the information of the visible to the infrared or visible to the thermal. You must be very careful, the band should be the same. So we have done, next one. So flow diagram for subpixel. For this purpose, as I have already mentioned, once I was mentioning the data set used, that this data IRS, this data we have used. So mixing pixel, spectral unmixing method we have used, and estimated the hotspot fractions, and that will be the area of the hotspot. Next one. So due to the coarse resolution of AVHRR image, it is not possible to identify any pure pixel from the image. So we need auxiliary high resolution satellite data, as I have already mentioned, and for this purpose we have used the list data. Next one. So raw data, again the same thing, detected hotspot. Here we have used the IRS P6, and this has a resolution of approximately 12.5 meter. Pre-processing pixel plot. Just take a look at it. Yes. So this is the. You can see that this is the river. This is the IRS data, and this IRS data is more clear because its resolution is approximately 23.5 meter, and its resolution it is more clear than the AVHRR data, right? And pixel plot index. So we have calculated the pixel plot index. That is a very important once you are doing the subpixel analysis. So how much pure pixels are there? Pure pixel means the pixel which have only one kind of information. For example, if it is a 23.5 meter square, it means either it has a urban or water bodies or agriculture or something like that. So that is the pixel plot index is a very important. So with the coarse resolution, it is not possible to get the pixel plot, while as it is a with the high resolution, it is possible to get the pixel plot index, and we got the pixel plot index. So extraction of purest pixel, we have extracted the purest pixel. This is the list image, and in this image, purest pixel means the pixel which only contains the hotspots. This is the purest pixel. This is the and then you are able to fuse the information from one image to another image. Otherwise, if it has more than one information, then it is not possible. So this is the purest pixel. Right. So then we have applied the CEM, constant energy minimization technique, and this is the again one method to minimize the error. Because here what we are trying to minimize the maximize the purity index, pixel purity index. So this is the minimization of the error for the two. Next one. And then again mixed pixel information, pure pixel information we have viewed. Design a FIR filter, subject to minimize the average filter output energy, then FIR filter output estimation, estimated hotspot fraction. Because our aim is here to estimate the area with the coarse resolution. Next one. So mixed purity image, hotspot fraction image, we have got it from 2004 data 1, 2004 data, and same thing. Next one. So estimated total area occupied hotspot is approximately 7.68 kilometers square of the total image area of 2000 kilometers square. So very accurately, if you can see that, I think that this is the mixture of this is the hotspot intensity level, and this is the mixture of the harmonic analysis image also, how the intensity as well as area is changing in the different years while seeing this one. So we are able to detect estimate the hotspot area with the coarse resolution also. Next one. So in fundamental component image, high pixel value indicates that the corresponding hotspot, and this is the linear duration. Okay, next one. So by this we can conclude what I can conclude next. So what I can conclude in a very short way, there are always ways by which we can define or we can apply the different approaches in a different way to maximize the use of the freely available data or to minimize the cost. So there should be the aim of the research, that how we can minimize the cost or how we are giving our results for the end user. Next one. So what I have seen that all these results are there, what I have compared and discussed. Next. So develop novel technique to estimate the area of hotspot by employing subpixel analysis techniques. Next. So this is the final conclusion by all 4 or 5 methods which we have applied, and all these are giving a very satisfactory result, more than 80% of this. And this product already I have supplied to the CMRI, Central Mining Research Institute. Earlier it was CMRI, now it is a CMFRI, Central Mining and Fuel Research Institute. Next one. So what we are trying to develop, already one thing I have developed, hotspot monitoring system with our algorithm. So just anybody can put the freely available data, and by this output we can see that with the time series analysis, with all the options will be there, and with that you can see that either your hotspot area is increasing or decreasing, or what the actual, at least a rough hand results you can get. So whether you want some major precautions, you can take the major precautions. Next. So question and answers if any. Next. Thanks for this.